So in this short video we are going to discuss this problem. It states that the ammonia oxidation process occurs over a catalyst as 4 ammonia plus 5 oxygen gives 6 water plus 4 NO. Now air is supplied such that oxygen is 20% in excess of that required for the complete conversion of ammonia. The mole fraction of oxygen in the inlet gas mixture, that is ammonia plus air, is. So they are asking to calculate the mole fraction of oxygen in the inlet gas mixture. So this problem was asked in GATE 2018. GATE 2018 and it is of 1 mark. So we will solve this. It is a very easy question. So if you see this reaction, what it states is for 4 moles of ammonia we require 5 moles of oxygen. So now we will take a basis. We will take a basis and we will assume that the feed contains. So we will take a basis of 400 moles of ammonia. 400 moles of ammonia. Now with 400 moles of ammonia, what is the theoretical oxygen which is needed? The theoretical oxygen which will be needed for complete conversion of 400 moles of ammonia will be 500 moles of oxygen, because it states completely that 4 moles of ammonia require 5 moles of O2. So here it will be 500 moles of oxygen will be required. Now what they have said is 20% excess air is supplied. Air is supplied such that oxygen is 20% in excess to that required. So if it is 20% excess, then 500, if I take 20% excess of 500, I have to multiply a 1.2 with this. So this is the moles of supplied oxygen. Moles of supplied oxygen. Moles of supplied O2. So this, after calculating, what we will get is 600 moles. So this is the amount of oxygen which is supplied with the ammonia. So 400 moles of ammonia is supplied with 600 moles of oxygen. Now what they have said is the mole fraction of oxygen in inlet gas mixture. This is what we need to find. So now the inlet feed, if I consider this as my feed, it contains ammonia. It contains ammonia plus air. So now this air can be further broken down into oxygen, nitrogen, etc. We know that air contains 21% oxygen and 79% nitrogen. So this is what we know. Now in the feed they have supplied 600 moles of oxygen. So if I know that 600 moles of oxygen has been supplied, then what is the total amount of air which is fed in? So total amount of air will be nothing but 600 divided by 0.21, because 0.21 of the total air is the amount of oxygen. So if I know the amount of oxygen and if I divide it with 0.21, I will get the moles of air which has been fed in. So this turns out to be 2857.14. These are the number of moles of air which has been supplied. So now I know that in this inlet feed, the ammonia is 400 moles. The ammonia is 400 moles. So let me write this down. The ammonia is 400 moles and the amount of air is 2857.14 moles. So the total moles, this will be the total moles. The total moles which has been fed, is equal to, this will be 3257.14. So this is the total moles of feed, that is ammonia plus air, which has been fed. Now the amount of oxygen in this is 600. The amount of oxygen is 600. So now the mole fraction of oxygen, mole fraction of oxygen in the inlet feed, is equal to 600 divided by this entire thing, which is 3257.14. So this is equal to, so if you evaluate this, what you will get is 0.18. So this is what the mole fraction of oxygen in the inlet feed is. So this will be 0.18. So I tried to solve this problem as quickly as possible. So that was all about this video. We will solve another problem in the next one. Thank you.